If you've ever tried to build a RAG agent for like a real-world application, you know the pain. It's just this massive technical headache that can stop a project cold.
Oh, it's brutal, the infrastructure alone. You're trying to figure out document chunking, getting the right vector embeddings, and then you have to stand up and manage a whole vector database. Pinecone, Milvus, whatever. It's a full-time engineering job.
Exactly. And the costs just start climbing right away.
Yeah.
But what if there was a way to just skip 90% of that?
Well, that's what we're talking about. Here's the headline that should make you just stop. We're talking about indexing a 121-page PDF, a huge knowledge base, for less than 2 cents.
Welcome back to the Deep Dive. Today, our whole mission is to unpack Google's new Gemini File Search API, because it looks like it completely automates the hardest parts of retrieval augmented generation. And you can do it with a simple no-code tool.
Yeah, and let's just make sure we're on the same page with RAG. Retrieval augmented generation just means using your own documents to ground an LLM to make sure its answers are based on some kind of truth, not just its training data.
That grounding is absolutely everything. So here's what we're going to do. We'll walk through the insane cost savings, then the super simple 4-step workflow, and then we have to talk about the limitations. Because, if it sounds this good, there got to be some catches.
Okay, let's get into it. Let's see just how simple this really is.
So the traditional way of doing RAG, it really was a gauntlet. It wasn't just, point an LLM at a file. You had like a dozen different things you had to build and then maintain.
Absolutely. You had to worry about all the different file types, how to ingest them, adding metadata, and then the chunking. Oh, the chunking. Recursive character splitting, running every single one of those little chunks through an embeddings model.
And only then, after all that, could you even put it in the database.
Right. It was so intense.
That's just the definition of high friction. So how does this Gemini File Search solution get around all that? What's Google actually doing under the hood?
It just simplifies the whole thing from the developer side. You just upload the file. That's it. Google takes care of the chunking. They generate their own embeddings, and they handle the storage. That entire pipeline is managed for you.
So the big idea is you don't have to build your own search system. You don't have to set up a vector database or worry about keeping things in sync. You're just using their pipeline.
Exactly. And what's really interesting is that their chunking is probably way better than what most of us would build. It's not just split every 500 characters. It understands the document's flow and structure.
Yeah, that's a great point. And just to be clear for everyone, when we say embeddings, we're just talking about turning words into numbers, right? Into a mathematical format so a computer can search them incredibly fast.
That's it. It's just turning language into math for quick comparisons.
So if you had to pick just one thing, what's the single biggest piece of complexity that this new Gemini method just gets rid of?
It's that whole chain of manual document splitting, generating the embeddings, and then managing all the separate search infrastructure to glue it all together.
Okay, let's talk about the money, because this is where the story gets kind of wild. You said you could index a huge document for pennies. How does that pricing actually work?
The main thing is that you really only get charged for that first step, the upload, the indexing. And the cost is just tiny. It's 15 cents per 1 million tokens.
Let's put that in real terms again. That 121-page PDF was, what, about 95,000 tokens?
Yeah.
So the math on that really is less than 2 cents. It costs basically nothing to load your knowledge.
It's incredibly cheap to get the data in. And here's maybe the biggest deal right now. Storage is free.
Well,
totally free. You are not paying by the gigabyte for all those vectors to just sit there on Google servers.
okay, but what about querying? If I have this agent running all day, am I going to get slammed with retrieval fees?
No, not for the retrieval itself. You pay the normal rate for using the LLM, for Gemini 2.5 Flash to generate the answer, but the actual cost of pulling the data from your store is, for now, absorbed.
I saw the cost comparison table.
Yeah.
And it's a little bit shocking.
Right.
Let's say you have 100 gigs of data and you run 1 million queries in a month.
Right. For a traditional setup, with something like Pinecone plus all the compute you'd need, you're looking at hundreds, maybe even thousands of dollars a month. Easily.
Whoa.
Yeah. And with Gemini File Search, that whole first month, including the one-time indexing fee for all that data, is about $47.
Wait, $47?
Yeah.
For that kind of volume?
Yeah.
That's the moment of wonder right there. I mean, imagine what you could build, what you could experiment with if your entire knowledge base infrastructure costs less than a pizza.
It just opens a powerful RAG to everyone. It's a huge democratization. It's moving away from spending big capital on infrastructure to just a simple operational cost.
So beyond that initial tiny fee, what's the main takeaway on costs for someone just starting out?
The fact that storage is currently free, that removes the single biggest recurring cost that you always have with traditional vector databases.
Okay, so the money part is a no-brainer. Let's get practical. Let's talk about building this thing in NAT, which is basically a tool for visualizing API calls.
Right, and you only need 4 of them. 4 simple HTTP request nodes. It's like stacking Lego blocks. It's really that linear.
Okay, walk us through them. What are those 4 steps doing?
Step 1 is create store. Think of this as just making a folder. You're creating a permanent named index on Google's side where your documents are going to live.
Got it. Then you have to get the actual file up there.
Exactly. Step 2 is upload file. But this is just a temporary step. The file is in the Google Cloud environment, but it's not connected to your store yet. It's just sitting there.
So you have to link the file to the folder.
That is step 3. Move file to store. This is the magic step. This is what actually kicks off the indexing and makes the file a permanent part of your knowledge base.
And then finally, you can ask it a question.
Step 4. Query the store. This is the request you send to the Gemini model, and you tell it, hey, use this specific knowledge base to help you answer the user's question.
Okay, a quick but important detour on setup. Getting the security right. The original notes mentioned some confusion in Google's documentation. So what's the right way to do authentication in A.D.?
The best way is to not paste your API key in every single node. That's messy and insecure. Instead, you use AnyDen's generic credential type.
Right, and you use the query auth option specifically.
Correct. You just tell it the parameter is called key, and you paste your Gemini API key in there once. Then all 4 of your nodes can just reference that saved credential. It keeps everything clean and secure.
And why is getting that authentication right so important, even if you're just building a quick prototype?
Because we should always be building securely from the start. It just prevents you from accidentally exposing your key in a bunch of different places.
All right, let's talk about actually running this. You said step 3, moving the file into the store, is the critical one. What happens if you forget to do that?
The file just stays temporary, just floating out there in the cloud, and it'll get deleted after a little while. It never gets indexed, so your agent can't see it. You have to make that link to the store.
Okay, so once it's linked and we're ready to query it in step 4, what does that API call look like?
So we're using the Gemini 2.5 Flash model, and the most important part is in the JSON you send. You have to include a search config parameter and paste in the unique store name ID that you got from step 1. That's how you tell the LLM exactly where to look.
So if you get that ID wrong, the agent just defaults to its general knowledge. It doesn't use your documents at all.
Precisely. It's the whole key. And then, of course, you need good prompt engineering. We used a clear instruction. You are a helpful ag agent. Use your knowledge-based tool for truth. Cite your sources.
And there was that weirdly specific rule you found. No punctuation, quotation marks, or new lines. Why that?
Yeah, that's just a practical little hack. It's to stop the underlying API from throwing a JSON error when it tries to pass data back. It just ensures the data transfer is clean. A strange quirk, but it's necessary for stability right now.
So let's get to the results. You threw 3 really different documents at it. The official rules of golf, an Nvidia press release, and an Apple 10K filing. How did it do?
It did extremely well. For instance, I asked the golf PDF, what happens if your club breaks during the middle of the round? It came back with a perfect cited answer about how you can continue using it or have it repaired legally.
And what about across multiple documents? Could it find a specific number from the Nvidia filing?
Yep. Asked for the Q1 2025 fiscal summary. It correctly pulled out the $26 billion in total revenue and the $22 billion in data center revenue, and it cited the press release correctly.
And the overall score, after 10 really tough questions across almost 200 pages of documents, was a 4.5 out of 5 for correctness. That's amazing for a setup that took minutes.
What's so impressive about that 4.5 out of 5 score is that it got there with basically 0 complexity, 0 fine-tuning, and 0 maintenance from the person building it.
So we know it's simple, we know it's cheap, we know it's accurate. But now we have to be realistic. This isn't magic. Where does it fall short? What are the limitations?
Okay, limitation number 1 is a big one for any real application: data management. Right now, Google doesn't have any kind of version control for the files in your store.
So if I have my Q1 report in there, and then I upload the Q2 report, and now I just have 2 of them.
You have 2 of them. and the store gets cluttered with old conflicting data, your agent might pull from the wrong one. So the only solution right now is manual. You have to track your own versions and remember to delete the old file before you upload the new one.
I appreciate you sharing that vulnerability. It feels like no matter how advanced the tools get, we're always stuck with data hygiene problems.
Oh, yeah. I still wrestle with prompt drift and messy data pipelines in my own complex projects. It's just a constant, frustrating challenge in this field.
And what about the quality of the documents themselves?
Garbage in, garbage out. That rule absolutely still applies. Gemini has OCR, which is great, but it's not a miracle worker. If you upload a blurry, poorly formatted PDF, you're going to get bad answers. You still have to do the cleanup.
Okay, and limitation number 3. This one's about what it's actually good at.
Right. This system is fantastic at finding a needle in a haystack. A specific fact, a number, a rule. It fails completely when you ask it for a holistic summary or to understand the whole document.
So you couldn't ask it to, say, summarize a 500-page book.
Exactly. We saw this in our tests. I asked it how many total rules are in the Gulf PDF, and it answered 5. It couldn't see the whole document to count them all. It just found the 5 nearest chunks that mentioned the word rule.
And the last one, which is maybe the most important for businesses, security.
You have to remember your documents are on Google servers, so you have to be really careful about what you upload. No sensitive PII, personally identifiable information, and no top secret company data.
And you need to think about compliance.
Absolutely. GDPR, API. If you have really strict data sovereignty or security needs, you might still need to build your own on-premise solution. This might not be for you.
So just to be crystal clear, if your goal is to summarize a huge entire document, should you use this?
No. Its architecture is built for finding facts inside chunks, which limits the kind of holistic understanding you need for a good summary.
Okay, so let's pull all this together. The big takeaway here seems to be that Gemini File Search just massively lowers the barrier to entry for RAG. It's a huge leap in simplicity and cost-effectiveness.
The verdict is pretty clear. You can set it up in 30 minutes. It's basically free for most normal use cases, and it delivers really high accuracy. That 4.5 out of 5 is no joke.
Those 4 simple API calls are automating what used to be weeks of painful infrastructure work. It's pretty incredible.
So who should be using this right now? I'd say developers who are prototyping org ideas, small businesses that need a simple internal Q&A bot, or maybe content creators trying to organize a huge library of their own work.
And who should maybe hold off for now?
Big companies with really strict compliance rules, anyone who needs total control over their data, or use cases that are all about deep, full document summarization instead of fact-finding.
It really lets you change your focus. You can stop worrying about the RAG infrastructure and just start building a valuable agent.
Which leads to a really interesting thought. If this is the trend, if R just becomes a cheap built-in feature of these models, what does that mean for the future of, say, a specialized vector database engineer?
Is that entire job going to change?
That is a fascinating question to think about.
It really is.
All right, go out and build value, not infrastructure. We hope this deep dive gave you the clarity you were looking for.
Until next time.